All righty. So, I mean, the questions are the same as they were in the book. I didn't do them all. I'm just saying.
Yeah.
That's the rumor that I heard. So, let's get started. I mean, I did watch Sister Lemon's exam review. The first part. I'll watch the second part when we're done here tonight. But that was very helpful if anybody didn't watch it yet. Just kind of how she went through and how the thought process of how to figure out which one you should be using and stuff. So,
right. I watched
the public service announcement.
Yeah, I watched those, and I'm glad that I did, because I think those were the ones where I didn't do well on the exam.
Bless you.
Bless you.
That was my wife, 40 feet away on the other side. I bet you that I think that's where I didn't do well. So I would, if I had to do it over again, I think I would watch Sister Lemon's review several times. But I did okay.
Thank you for that.
I did okay. It's just I still don't feel very comfortable.
Right.
But there were a lot of those types of questions on the exam that we haven't had before.
Okay. Well, that's really a lot of this group meetings, a lot of that too. So that's
like
that's
this
helpful.
question 2, for example. There's a lot of these kinds of questions.
This is where I lack. I do not.
Yeah.
I need help there too.
Yeah.
Okay. So, in an article in the Journal of Small Business Management, successful startup businesses in the United States and Korea were compared. One set of data compared educational level of people who manage successful startup companies in the United States and Korea. You want to determine if education levels of managers of a successful startup company is independent of the country they are from. Which hypothesis test would be the most appropriate for the analysis? So, well, we know it's categorical.
Mm-hmm.
So you're not using ZT, paired, independent, or ANOVA. So it's it's one of the bottom 3, right?
Yeah, I put G for this one, the test of 2 proportions.
I did chi-squared.
Well, it's not more than 3. It's not comparing 3 things. So it's comparing the United States and Korea.
But I thought it was comparing
the
education level.
You're right. It has the education levels. So you'd have all of those and then United States and Korea. So it's like, here's what you have in the United States, here's what you have in Korea, but there's, high school, undergrad. So I agree with you that on the James and Ed, what are you thinking?
I kind of thought it was going to be the independent sample t-test, but I think I'm wrong.
It's not independent sample T because it's not quantitative. That's only if you have a quantitative data.
Yeah.
So it's categorical. So it's a proportion test. So it's either the 1, 2, or the chi-squared. I don't know how you say it.
I vote for test of 1 proportion.
Well, you're comparing more than that because you have 5 different educational levels.
Yeah, I don't think.
I thought it was kind of like in lesson 19 when, we had all that data and it was spread out. And what was it? It said, oh, God, now I can't even think of it when it was, 4 or 5 across, but it was comparing 2 different countries. That's why I felt like it was the chi-squared.
No, I agree with you. On that. So.
Yeah, that's what I think it is.
You know what? The word independent is in the question as well. And that's one of the clues that Sister Lemon mentions to us, like keywords.
Right. So then you're looking at independent of more than 3 things because there's high school, undergraduate degree, master's degree, doctoral degree.
So be the chi-squared.
That's chi-squared.
Okay. That makes sense.
Oh, you know what? I had that in my notes. Okay, I should just pay attention to my notes.
A human resources manager reported from a recent involuntary reduction in force you are an attorney and want to determine if age discrimination was a factor. The company reported the number of employees in two groups, 40 years old or younger, 40 over 40. They also reported the number of employees in each group who were terminated. So again, this is not quantitative because they're just saying 40-year-olds over 40. So you don't do ZT or ANOVA. It's one of the bottom three.
And I thought it was B, test of two proportions.
That's what I got.
Correct. That's what I have. I don't know if that's correct, but
Yeah, I think that sounds about right.
okay. The survey was conducted by a group of state lotteries. A random sample of 2,046 adults were completed. A total of 248 were classified as heavy players. Of these, 152 were male. You wanted to determine if the proportion of male heavy lottery players is different than the proportion of males in the population, which is 48.5%. Which hypothesis test would be most appropriate for this analysis?
I did the test of two proportions again.
Then I thought 1 because we're just testing males.
Let me see.
The proportion of heavy lottery players is different than the proportion of males in the population. So we have to be looking at two different. But again, we're going to be looking at a percentage. So does that make it an independent sample t-test?
Right.
Because what we're going to, at the end of the day, we're going to say there was 48.5% of this, and you know what I mean? You're looking at the percentage. So they want to see with the, although it's saying proportion, which that's supposed to be one of the context words, as she says all the time. Want to determine if the proportion of heavy lottery players is different than the proportion of males in the population.
I'm thinking test of one proportion.
That's what I have written down.
That makes sense. I guess it only has a total of, the 248 and of those 152. So it doesn't have two blocks sets of numbers, huh?
We're just working with the 152 males.
Yeah, I agree.
Right, so of the 248 were classified as heavy players. Of these, 152 were male. So now we're just looking at our males out of the 242 that were heavy players. And we want to determine I have test of one proportion clicked off on my, when I was doing it. So is that the consensus?
Test of one proportion. That's what I'm choosing.
Okay. I like that.
Two different combination locks. One of the locks turned clockwise first and the other lock turned counterclockwise first. They have 25 students to participate in the study. Each student was given the combination of each lock and asked to open the locks. The time it took to open each lock was recorded. They want to determine if one of the locks is easier to open, which hypothesis test would be most appropriate. So now we know this is quantitative because we're looking at time.
I got D, independent sample T.
Well, and I thought this one was tricky. I chose paired because the clue's each student. And so you have one student with two locks, counterclockwise and clockwise, and then the next student also has to do counterclockwise and clockwise. So that's why I chose paired.
That makes sense now because they were seeing if there was a difference, right?
Yeah. Right. They were seeing if there was a difference between the two, and each student was given both locks.
Yeah. See, I read it wrong. Okay. Yeah, that makes sense.
And you know what? I kind of think they're not the same locks or the same students, so they're not. Well,
when you read, and I had to read this twice. So only 25 students, and then it goes, each student was given the combination to each lock.
Yeah.
Asked to open the locks. The time it took them to open each lock was recorded. So it's a little bit vague about, you know, did half of them have the clockwise? Did half of them have the counterclockwise, and who could do them faster? But I think when it's each student was given the combination to each lock, it's showing that every student had to do both. And so every student was timed. So the counterclockwise, how fast did you do it? The clockwise. And then same with student, you know, 1, 2, 3, 4, 5, 6, 7, down to 25. And so, the test wasn't like against each other. Like, could person A do it better than B? It was person A, what was their time for each of it? Person B, their time for each of it. So the pairs are the clockwise and counterclockwise. Which one is faster to open for these 25 people overall?
They want to determine if one of the locks is easier to open. So they're not trying to determine if the student is better at it. They're trying to determine if the lock. So see, I'm looking at it as an independent sample t-test because I'm thinking the one lock had nothing to do with the other lock.
Well, I think they did, in that one was clockwise and one was counterclockwise. And so you want to know, the only way you can tell if one's faster to open than the other one is to have 25 random people, for instance. It doesn't have to be random, but you're going to have 25 different people open those same locks and time them so that you can get a better feel for which one is easier to open, the clockwise or the counterclockwise. And the only reason you're using the time amount is just to see which one's easier, rather than saying, did one spin faster than the other? For Joan, if you felt it was the independent, and you felt it because why? Because that will help me understand better the independent too, even if I felt like it was the paired.
Well, and I guess I have to think this through, right? So if you said the group, you know, the group of locks that are I guess it is paired, because if you say, okay, if this bunch of locks are counterclockwise, that means that this group in B has to be clockwise. Because you can't give them 2 counterclockwise and you can't give them 2 clockwise. They each have to have one of each. So what they have in group 1 determines what they'd have in group 2. So then it would be paired.
And are there 50 locks, or are there just 2, a clockwise and a counterclockwise? You know? So I kind of looked at it that there were 2 locks, and, you know, person A came in and they did the first lock, they timed them, the second lock, and, you know, you determined whether it was the clockwise or the counterclockwise, as opposed to 50 locks, everybody's in a room doing it at the same time. Because I don't think it was about who was fastest. It was just which lock.
It's about the lock.
Quicker. Yeah, yeah.
What are your thoughts, Nicole?
Well, I initially did the independent one, and then now I'm leaning towards a paired one.
Me
but
too.
But it's hard. It's hard because they were each given, one lock that had the clockwise and one clock that had the counterclockwise. So it seemed like they would have to be paired. I don't know. Oh no, it's hard.
The question's a little vague. Like, if it's paired, they could have worded the question a little bit better to be clear about that.
Yeah, because it was almost like your data would have to depend on the other one to see if it took them more time or less time, would be dependent on that student's exact times.
Right.
You know what I mean? So that's why I'm kind of leaning towards a paired, because you would have to know the time exactly of that one student doing both of the clocks.
Oh, right, because what if it took a whole minute for one person to do one lock and a minute and 3 seconds or whatever to do the other one, but another person, it took them 30 seconds and 35 seconds. You're not comparing the person, you know, one person to another and how fast they did it. You're just, could you do it one or the other faster than another one? And we want to see that with 25 people. So overall, could 20 of the people could open the counterclockwise faster than the clockwise, for instance.
Yeah.
And so the only reason that you're timing it is just to say clockwise or counterclockwise.
Mm-hmm.
Right. Which one's quicker?
You're not even keeping the time except to just show that one was faster than the other, right?
Yep. So we're going with paired t-test.
What do you think, James?
I think it's independent. I'm still stuck on number 3.
Oh, number 3?
We can go back to that at another time. So
These are-
the way I look at it is paired test is taking something like, let's say the effectiveness of like a training program, right? So one way you can effectively determine if the training program is successful is if you test them before the training program and then you test them after the training program. I felt like that's a paired sample test. And so I don't know, maybe I'm just wrong, which I can be a lot of times. So that's what I kind of more or less think is a paired sample test.
Well,
Like-
is a paired also kind of like, and maybe that's more dependent, I don't know. Like when we've talked about ones that are like, when you involved a brother or sister, you couldn't test someone who was an only child, for instance, because they had to have had a brother or a sister, or if it was a husband wife, you couldn't do a single person. You had to do, a husband wife to see, and that's kind of where my mind went with the clockwise and that counterclockwise with the husband wife thing.
Well,
They were-
that's how it's explained. You determine who's in group 1. So randomly they pick, and they say, okay, well the group 1 are going to be the clockwise locks. So if that's the case, then the group 2, you have to take it counterclockwise because you can't have 2 clockwise. You need 1 of each. So that's why I'm thinking group 2 is determined by what's in group 1.
But I
didn't
didn't
put 50 locks out there and everybody just took 2 because somebody could end up with 2 counterclockwise and somebody could end up with 2 clockwise. So
Right.
group 1 determined what was in group 2.
But we never talked about them being grouped. They're just 25 students with at least so far, we don't know, is it like 50 locks or is it just 2 locks that 25 people come in a room even separately? Person A comes in, does the clockwise and the counterclockwise, you timed them, they leave. Person number, B person comes in and does it, then C person, you could even have it done over days and days and days. Rather than 25 people in a room all together with 50 locks.
Right.
Yeah, it's kind of unclear. It's really wishy.
Yeah, there's a lot of confusion. I'm still thinking independent. When when I think a pair, I still think that, brother, sister, husband, wife, twins, or after, not just, they're both locks in each hand and they're both students and, that are doing the locks. They appear to be paired, but they're not really, paired. You could have students in one group, and you could have priests in another group, nuns in another group, and they have nothing to do with each other. And you could have a combination lock that spins one direction and a key lock that goes in the other direction. They're not related. They just happen to be locks. I think I still lean towards independent sample t-test. But remember, I took the exam and got a bunch wrong, so.
Well, okay, so for question 5, I think we're all going to pick what we want here.
But how are we going to know which is wrong when we submit our questions? So we can
We're
learn.
not going to see the answers.
You don't see the answers. We'll just know if it's wrong.
Well-
I think it's only paired or independent. It's not one sample or
Okay.
Don't we find out the answers at the end on a group meeting quiz like this?
Oh yeah, I guess we do. I guess we do.
Yeah,
Yeah.
yeah. It's not like an exam. We always find out the answers at the end.
Yeah, you
Right.
get 2 chances, right, for this one?
Yeah.
Yeah, yeah.
Okay, good.
Okay. Guess I haven't been paying attention, have I? For the next 3 questions, identify the one confidence interval that is most appropriate for the given situation. A bank employs 2 appraisers. When approving borrowers for mortgages, it is imperative that the appraisers value the same types of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers had recently valued. Which confidence interval would be most appropriate for this study?
And I chose paired.
This one I chose paired T confidence level.
Yeah.
I have paired as well. Because they're the same properties.
Uh-huh.
And see, this one was the one I reflected back to the previous question. Think of the locks as property. You got a counterclockwise property and a clockwise property. Anyway, we'll come back to that
Okay.
one.
We're going to be going back to a lot of them, and there's 45 on this one tonight.
I know.
In the Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors reported they were satisfied with their career path was reported. The same data was also reported for accounting majors. You decide to construct a 95% confidence interval to see if the observed difference is significant. Which confidence interval would be most appropriate in this study?
I said 2
2
proportion.
proportions.
Sorry, which one are you guys on?
7.
It's number 7, number 6 on your paper, but 7 online.
Okay.
Yeah,
Okay.
7.
What'd you guys get for that one?
I have 2 proportion as well.
Proportions, the last one.
That's
The
what
la-
I feel.
Okay.
Right. Double stuffed Oreo cookies are supposed to have twice the filling, and we've done this one before, so
Yes.
Like
you
we're
and some
supposed
friends
to
decide
remember
you
it,
want
though.
to know if that is true assertion by the company who makes them. You take a sample of 55 double stuffed Oreos and measure the amount of filling in each one. You need to construct confidence intervals to estimate the true mean filling amount of double stuffed Oreos. So it doesn't tell you what the mean is here, so that automatically makes it a T.
Yeah. I did 1 sample T.
Yep.
Because while it's telling you double stuff, supposed to have twice the filling of Oreo, they're not doing a comparison between the 2. You're just doing double stuffs.
Well, they're not giving you the mean. They're not
Yeah.
giving
Right.
so,
But the only reason I pointed that out is it's not a paired samples T confidence.
oh yeah, no.
I agree. It's the second one.
Yeah, 1 sample, right?
Yep. Which one of the following best defines the notion of the significance level of a hypothesis test? The first one is the p-value definition.
I got the type 1 error. I don't know if that's right or not.
Yeah. I'm certain it's not type 1 error because that one has to do with if I remember it, if you get the if you keep the null and you're supposed to reject it. I think that's the type 1 and type 2 stuff.
Right.
I think number 9 is the first one. That almost word for word is in my brain embedded. And it might be incorrect, but and that word
Right.
extreme is a key word that I recall.
So if you reject the HO when it was true, then that's a type 1 error.
Well,
Yeah, because the first because the first one says whether it's true or not. It has to be one way or the other, right?
Yeah, okay, here's what it is. A type 1 error is to reject the null when the null is true. And a type 2 error is to fail to reject the null when the null is false.
Right. So it's certainly not the first one. That's the p-value definition.
Yeah, so
And
neither
it's
one of
not
those.
and it's not the third one.
Yeah, type 1 and 2 errors don't really have to do with significance levels.
Oh, that's true. Probably.
Yeah, I don't
No.
I don't know this one at all, though.
You know what? I will look it up real quick. Oh, here it is.
I put
This is straight from chapter 7.
type 1 error, so
Yeah, lesson 7 summary says the p-value is the probability of getting a test statistic at least as extreme as the one you got, assuming HO is true.
Right. So we know it's not that one. Because we're at question 9.
Yeah, that one's the answer for the next question for the p-value.
Oh, oh,
This one's for the level of the significance level of a hypothesis test.
yeah, I put type 1 error.
Okay, that's what I think.
That's what I put too. So, and then we said question 10 was the probability of observing a sample statistic. That's the definition of a
oh,
p-value.
got it.
Somehow that's ingrained in my brain.
There we go.
Right,
That's
nice
ingrained.
long sentence.
The only thing that I can, that and the central limit theorem, those
Yeah.
are the two I get. Suppose you create a 95% confidence interval for a mean and get 10 and 20. You have been told to report this by saying something like, we are 95% confident that the true mean is between 10 and 20. Exactly what does that mean? So this is the second one.
I think so.
Yeah.
Oh, no, wait.
The 95% of all 95% confidence intervals, right?
Yep.
Yep. Yeah, that's it.
That's what I got.
Okay.
I was just trying to catch up with my paper and how it matches the quiz online. You know what I mean? So I'm like, hold on, I gotta make sure that what I circled on my paper matches with what I see. Because they're not in the same order. So
Right.
So you take a sample random of 100 adults from a town in the Western United States to determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion or percentage of people in town who invest in the stock market is 30%. What is the mean of the distribution of the sample proportion?
I think this is the one where it says p hat equals p.
Right, it's the same.
So it's
0.3.
30. Yeah.
Right, so it's still 0.3 or 30. Okay. What is the standard deviation of the distribution of the sample proportion?
okay, hold on, go back because I'm still catching. It's 0.30, not 30, right?
Yeah, 0.3.
Right.
Oh. All right, thank you. Okay.
So what is the standard deviation of the distribution of the sample proportion?
Got 0.046. Right, so it's 0.3. That whole thing with 1 minus 0.3 over 100 square root.
Are you guys on 12?
What?
Are you guys on 12?
12,
Yeah,
we got 0.3.
Okay, and then the next one is at 0.046.
That's what I got.
Okay.
Yeah.
I have that as well.
What is the probability that your random sample of 100 adults will have the sample proportion less than 0.25?
How do you do this one again? I was trying to figure it out.
Well, I think we need the applet.
Yep, that's the,
That's where I was
that's the-
going, is the applet.
First we have to determine the z-score.
Okay.
Yeah, which is, I think the z-score is 1.09.
and the question is less than 0.25.
So do you go to the applet and put 0.25 in the area part? Wait, what do you do? How do you do this one? I wasn't sure how to set it up.
What is the probability that adults will have some proportion less than 0.25?
I think it's the formula p hat minus p, but we don't have a p hat up there, do we?
Yeah, it's 0.3.
Oh yeah, okay. So
Oh, that's right. It has all of these. Oh.
So it's 0.3. Yeah.
So what's the formula, James? 0.3.
Let me make sure.
Please go sit down.
I'm fine. It's for you and Steven.
So I think isn't it 0.25, right? Let me see. 0.25 minus 0.3 divided by 0.046, right?
Divided by what?
0.046, which is the standard deviation.
Okay.
So it's the p hat, or it's it's p hat. No, sorry. It's the sample proportion minus p hat divided by the standard deviation. I think. That's for the z-score, and then we put that into the applet,
Okay.
which I got negative 1.087, or however you want to go.
And then you just, yeah, and then because it's less than, so then you just shade that left side.
Yeah.
Wow, herbal Martins are so nice. Like Martins usually are.
So 0.1401,
So close to each other.
14, like,
I got 0.138.
That's what I got because I got 0.1379 on my applet.
what do you have as the z-score?
1.09.
Oh, 1.1379 or 1.38.
So I got 0.138. Is that?
Yeah,
Yep.
that's what I got.
That's what we're saying.
Thank you. I didn't know how to set that one up. I had forgotten.
Acupril is meant to control hypertension. A clinical trial of Acupril 2142 subjects were divided into two groups. The 1563 subjects in the experimental group received Acupril. The 579 subjects in the control group received a placebo. Of the 1563 in the experimental group, 61 experienced dizziness as a side effect. Of the 579 in the control group, 15 experienced dizziness as a side effect. Let P1 be the true proportion of people who experience dizziness while taking Acupril. Let P2 be the true proportion of people who experience dizziness who did not take Acupril. I think we sold this drug. So I need to open.
Oh, God, Jimmy, you have somebody to learn with. See you guys later. Yeah, cool. Because that's the purchase. A BBC something.
So are we just using one of the spreadsheets for this?
I think I'm opening one now to see.
Yeah, that's what I'm doing. I'm opening mine too.
If it's saying P1 be the true population, the P2.
So it'd be a interval for two proportions, or a test for two proportions, right?
Right. So P, all right. Then I have to keep going back.
I can open up my thing too.
Two proportion. There we go.
So 61, 563.
Okay, so this is the one we're using the X1N1, X2N2.
I think so, yeah.
Now, Ed, you had a thing on the side of yours to help with the X1, the N1, and the X2 and the N2, didn't you?
No, let's take a look.
What spreadsheet is this one in?
The categorical data analysis.
Does that look familiar?
Oh, let me look. Let me go back. I'm looking. I'm not. Most of the time, I'm not even look because I have one little screen. I'm not even looking at you guys. There we go. That's what I wanted to. Okay.
And this is after for the margin error.
P1. I'm still looking at yours. Let's see. P1, P2. I had meant to put that on there, and when I opened it up, I realized I must have had it on there and not saved it to help me. The P1 and the P2 to the left of the X1 and the X2.
Yeah. So 61 or 1463. And then 15 out of 579. 95% confidence interval. If we're right, I think it just spits it right into the
And then
I got 0.016.
and what's our type of test? I'm just trying to catch up here.
Categorical data analysis.
But down at the bottom, the P1's greater, the P1's less than, the P1's not equal to.
Not equal to, I think.
Okay, that's where mine was different. Okay,
Yeah, but that only changes the z-score. That doesn't change
right.
That'll be good.
margin of error.
So the confidence interval, that's that. On my paper, it's the E. Okay. And on the okay. Oh, the margin of error. We did have the margin of error. Margin of error 0.016.
Yes.
Yep.
That's what I
What I'm thinking.
Then the lower bound is
Negative
0.003.
Uh-huh.
Upper bound is 0.029.
Yes.
Mm-hmm.
Perform a hypothesis test to see if the proportion of experimental group subjects who experiences is different. All right, so the level of significance is 0.05. What is the appropriate null and alternative hypothesis?
It's equal and then a not equal to, right? For that one?
The very first one. Yes.
Yeah.
Right, because it says is different. It doesn't say if it's less or greater than. It just says is different.
Mhm.
Right.
Okay. The value of the test statistic
1.4.
1.458.
Yeah.
So that's where it makes a difference, right? So we when we looked at the hypothesis test there, that's why you want to make sure type of test is P1 does not equal P2.
Yeah.
Yeah. Yeah, because that changes.
That changes the Z. So it's
Mhm.
1.458. Does everybody get that?
Mm-hmm.
Because that was a lot. The P
Yes.
value p-value is 0.145.
Yes.
Is there sufficient evidence to conclude that the true proportion of people who experience dizziness while taking Acupro is different than the true proportion of people who experience dizziness while not taking it?
Mm-hmm. I put no.
So the level 5.
failed.
What did you say?
I put no and failed to reject the HO.
That's what I had to.
Because it's greater than. Right?
Yeah, from those check requirements and stuff.
Yeah.
So which one is it? Is it the first one? Oh no, not the first one.
The
is it
last
the
one.
last one?
Last one.
The last one, yeah.
So, I'm sorry, it's the last one, right?
Yeah.
Okay. Okay, use the following information to answer the next 4 questions. A survey was conducted of 1,279 randomly selected adults in 18 and older. They were asked, are you a morning person or a night person? The hypothesis for the study is being a morning person or evening person is independent of age. Being a morning or evening person is not independent of age. The results of the survey are given here. So we know that this is a,
That's a chi-squared.
yep,
A chi-square.
Oh, is that what it is? Okay. So we just fill this out.
yep.
Yes.
Morning is row 1, evening row 2. Calculate this test statistic. 6.579. Is that right, guys?
What'd you get?
Test statistic 6.579.
Yeah.
I
Yeah.
believe that is correct.
0.658.
Yeah. 6.580, right?
Sorry, 6.58.
6.58. All right, now I gotta go back here.
Well, don't we have to go out to 3 decimal spots?
Yeah.
580.
What? 0.
6.579. Yeah, sorry.
The p-value is 0.0866.
Or rounded to 3 spots?
0.087.
Mm-hmm.
Good.
Wait, for 22, is it 6.580 or 6.579?
9.
7, 9.
Okay.
Look at that strange wizard.
That is strange. Okay.
Should you reject the HO or not?
0.0. Save. I'm just making sure I'm saving all these. 0.087.
0.05, 0.87.
I put no, the P is greater than 0.05.
Yeah.
Yeah. Yep. That's the 4th one down.
Yes. So we're not going to reject the HO. So we failed to reject. We have insufficient evidence.
Right. We have insufficient evidence to say that being a morning or evening person is independent of age.
The third one down.
Yep.
I agree.
Is it the one that says not independent or independent?
The third one down does not have the word not.
Okay. So you want it to say person is independent of age?
Okay, wait one
Right.
second though. So we're rejecting.
No, we failed to reject.
For
We have insufficient evidence.
Okay, so, but let's think for a second, because we failed to reject, because the alternative is being a morning person or evening person is not independent of age.
What in the we if we a big stack
Let's see.
about the food and we were in her school?
But we want to restate the HO, which we have insufficient evidence to say that being a morning or evening person is independent of age. Don't we restate the HO?
No, I thought we restated the HA, that's why I'm questioning.
Oh, right. Okay.
Yeah, you restate the HA, right?
Right,
So it would be the 4th one.
is not independent.
Oh, yeah, okay. I agree. The 4th one.
Yeah. Okay. Thank you for going through that.
Yeah, I thought I remembered with that one, you always want to see the not in there with any of the chi or chi squared ones. The not independent. Because, right, it's either independent or not independent for that one, right? Something
Right.
like
Right, it's just, you have to, if we're restating the HA, we want to do the not independent, because that was the HA was independent, was not independent. Okay. A recent book noted only 20% of all investment managers outperform the Dow Jones Industrial Average over a 5-year period. A random sample of 200 investment managers that had graduated from one of the top 10 business programs in the country were followed over a 5-year period. 50 of these outperformed the Dow Jones Industrial Average. Let P be the true proportion of investment managers who graduated from one of the top 10 business programs who outperformed the Dow Jones over a 5-year period. 50 of these outperformed. let P be the true proportion of investment managers who graduated from one of the top 10. So it's 50. So there was 200 and we got 50 is our P value. Okay. Based on the results of the sample, create a 95% confidence interval of P. Input the lower and upper bounds below, round to 3 decimals. So that's the one proportion test.
This is where we have successes in our exam and our sample.
Right. So our success is 50. Our number is 200.
Mm-hmm.
To go back and read the question.
And then it's great. Our null hypothesis is 0.2, right? And then it's greater than.
And then greater than, yeah.
Right. I might have to set up like 2 screens to take this test, I think. I think it's just
I'll be right back.
Yeah.
because it's so frustrating going back and forth.
Yep.
All right, so input the lower bound. So the lower bound is 0.190.
Yes.
Point 310.
Yes. I think with
There is no crying at the beach, tell them. There's no crying at the beach. That's just unacceptable.
We're like torturing these kids with how much they cry.
yeah.
We have a total of 11 here, so.
Oh, then you feel free to cry.
Right? We're gonna go hide in the room.
You should be the one crying, not those babies. You should be the one crying.
Right. Oh, man.
So suppose you had been in charge of designing the study. What sample size would you need to construct a margin of error of 2% with a 95% confidence level using the prior estimator of a P.02 for the estimate? Okay.
And this one I always get messed up on. I'm like, how am I supposed to? I don't even remember this one. I mean, I just remember like that this was hard for me to get. That's what I remember.
So this one I finally found actually the sheet that Ed had.
The formula sheet.
Of the 4 of 4 sheet, the equation that I used was the Z star divided by 2 and the margin of error. And then you take all that and you square it.
Okay, I'm pulling it up right now. Let me.
It's in column 157. I wrote it down so I would know.
So the Z score is the 1.96 because it's 95%.
Uh-huh.
To 95%. The N.
7 in the 4 of 4 formula.
So the margin of error is 2%.
Mm-hmm.
And the prior estimate is a 0.2.
Okay, so let's see here. All right. So the Z, or we had to figure out the Z.
That's a 1.96. So it's a Z that you take when.
Oh yes. The 95% is 1.96. Okay. Yes, now I'm with you. And so the M is the 0.02. Okay, I'm with you now. Feeling like I have to switch from one mode to another. Like while I'm in one mode, I'm great, but then you ask me to switch to another one, and then I get messed up.
No.
Okay.
And then the prior estimate is also a 0.2, though. Right?
So let's see. So 28 is 2401.
Mm-hmm. That's what I.
Okay.
I think so.
Okay, see, I don't have that. And I'm using the spreadsheet. So
You're using Ed's spreadsheet 4 of 4?
yeah.
Yeah, that's that. Yeah, although I have
But see,
in my
you're
notes
supposed
the
to be doing
actual
it-
formulas, but that's the formula. Let me zoom in on that.
Okay. Just let me jump in here for a second, though, because you need to be using the next one down that says use the prior estimator of P starred whatever of a 0.2. So you need to put that in both of those. What you're looking at is just the Z and the M. You need to go to the next one down that says with prior estimate.
Oh, that one there.
And so
So for
the
lower bound and upper bound, did we get 0.190 and 0.310? Is that what that was?
yes.
And
So,
Nick,
Joan, when we're supposed to use row 165, are we saying M and P star is 0.02?
that's what it is, because we know that the margin of error is 0.2 and we know the prior estimator is 0.2. Because they tell you that. So, Nick, do you see what I mean there?
What do you guys get for 28?
Can you guys see it?
That's what we're working on now, James.
Well, I know, but people throwing out answers, right?
Oh, sorry. So we're on the 4 by, this you have to put in the Z star. The Z star of 1.96, and then the margin of error is 0.2. That's what it tells you.
Yeah.
And then it tells you the prior point estimator is a 0.2. So the number I get is 15.3664, which you always round up, right? So you go to 16.
What was your P asterisk again?
I got
0.02. That's what because it tells you that in the question.
our decimals.
says-
Our decimals
says
are
it-
wrong, but our numbers are the same.
It says that it's a 2% margin of error, and it says use the prior estimate of P.2.
Yeah.
So that's why. So I'm sorry, Nick, you stepped away.
Oh.
We're using line 165 because there was a prior estimator in this question.
Oh, okay. So which one do you use?
So you use the sample size with prior estimate.
Oh, okay. I missed that part of it.
row 165.
Right.
Oh, 165. Okay.
So it's 1.96, 0.2, 0.2. The answer comes to 15.3664, but you round up to 16.
Okay. Oh, you round up to 16?
Yes, you always have to round up to a whole number because you're talking about people and you can't have a portion of a person.
I always have to. Oh, yeah.
I'm making a note on that sample size with prior estimate. I'm round to whole number.
It says it on the spreadsheet.
I'll scroll over. This is what it says on the spreadsheet. See, I don't use my spreadsheet during the exams.
Oh, round to higher whole. There we go. I'm seeing it now. In the
Michael,
it wasn't reading in yellow. It's
it
in
right
yellow.
there. It's
Asked me to read it.
in a different color and it's highlighted, so it's right there.
Okay. So that's for 28?
Yes.
Okay. Thank you, guys.
So that's 16. Okay. Suppose you wish to see if there was evidence that graduates of one of the top 10 business programs performs better than other investment managers. Conduct a hypothesis test using a level of significance of 0.5. Wish to see if there was evidence that graduates of one of the top 10 business programs performs better.
So that sounds like greater than.
That's a greater than.
The second one.
No,
Second
it's
to
got to
last.
be greater than.
Second to last, right?
It's
See, I'm
the
always getting the
so it's the because the HO is always equals.
0.02. The P is greater, not the 0.02 is greater.
Right.
I will forever mess this up my whole life. I'm just resigned to that.
We just, I mean, the HO is always equals,
Right.
always. So you just have to find that the HO equals, and then either it's less than, not equal to, or greater than. There's only those are the
Well,
only
I
three.
chosen the second one. I had the HO right, but it's my greater than or less than, stupidity. I just don't know what I'm done.
Well, the James method is easy to remember. It's the alligator always eats the biggest one.
Gotcha.
But I know it as like reading an English sentence, like the open part takes up a greater amount of space on the page than the closed part, which takes up a lesser amount of space on the page.
Wait, can we stop for a second?
Yes.
Sure.
How did you get 16 for number 28?
Oh, share your screen.
Yeah, I'll do it.
So let's just talk real quick on the question. Suppose you had been in charge of designing the study. What sample size would be needed to construct a margin of error of 2%? You're telling me 16 people?
Correct.
That goes against almost everything we've learned in this class about the number of sample size, right?
Mhm.
So why would it be so small? Are you sure it's not 1,600? Because I got 1,537.
Figuring it out by hand.
Yeah, so that's why I might not have the right spreadsheet open. Is there a spreadsheet that we were using that?
This was the formula one that Ed had sent. It says 4 formulas and calculators.
Okay.
Well, for these ones, isn't it the 10?
For
That has
confidence interval, you have to have more than 10. Yes.
more than 10.
Don't smell it.
I'm just wanting to talk it out real quick.
No.
That's fine.
Let's see here.
It's really hard.
James, which do you think it's the formula that I
Because
have on my screen?
Wait, the margin of error is supposed to be 0.02, right? I'm just looking
Yeah.
at your screen right now.
Yeah, go back to your screen, Ed. Or wait, let me go back to your screen.
So, yeah, so 1535.
Oh, there you go.
0.02, yeah.
Oh, thanks for talking that out. There we go. Okay.
So 1537.
1537, that makes sense now. Oh,
Yeah.
okay.
But I
Because
think
decimal in the wrong place for M, right?
Remember, Joan, when I said we have the same numbers, but not the same decimal points.
Yeah.
So, okay,
Right.
good.
And by the way, I think I agree with James. I don't use this spreadsheet when I do the exams or the quizzes. I just do this by hand with the formula.
Yeah.
Because
I use the spreadsheet because, as you know, I can't use a calculator.
Oh, okay, yeah.
You all have witnessed that painfully, how I cannot use a calculator.
Yeah, I use the spreadsheets too.
So 28 is 1537.
Oh, thank you. Oh, cool.
Okay. So, James, are you okay with question 29 then?
So is it just P equals 0.2 and P is greater than 0.2?
Yes.
Cool. And then
Now we're all on 30.
Yeah.
the
Yeah.
second one.
What we're going to ensure the p hat is normally distributed.
I got the I got the 10 one.
Yeah. MP is greater than or equal to 10, and N1 minus p is greater than or equal to 10.
I thought it was the first 10, the one about 10, not the one about 5.
Yeah.
Okay.
Right.
Yeah, I agree. First one.
Okay.
The value of your test statistics. So now we're back to the categorical data spreadsheet.
Yeah.
Shoot me. Is 1.768. Am I still on the right spreadsheet?
That's what I got.
Yeah. It's like, wow, we have really been around the block with this. Can I just say that?
Yeah.
Seriously.
Oh man. Whoops.
And the p-value is 0.039.
Yes.
Okay, I got to type this in here. 1.768. And the P 0.039.
Yes.
So the p-value was 0.303, and it was 0.05, right? I have to go back up, 0.05. So it's lower, so we
They're both greater than or equal to 10, right?
correct.
Okay.
On the next one, I did yes, reject the HO. Is that right?
I think you're right, Nikki. Yes, I rejected HO.
Well, no, he's washing the phone.
So it's lower. So the P is low, reject the HO.
That means go no. I spit on him.
So the first one, I believe.
So he's a water helper.
Yeah, that's what I have.
He don't.
It happens to match my paper. Finally.
Yay!
Okay.
So
So
for the next, all the rest of the questions, my computer didn't want to download it as a Google Doc, so I wasn't able to do these ones. The 30 on.
okay. So
And-
well, we just did 33.
Yeah.
Right.
It won't let me open up the other
The blue scores.
data.
Okay. Because, to make it more difficult, let's just throw another wrench in there. Compare Pharaoh's ability to translate with similar computer translation software. Cohen, took a sample of 100 blocks of Spanish text, each which contained 300 sentences, and used Pharaoh to translate each of these to English. The blue score was calculated for each of the 100 blocks. These scores are recorded. He wants to use this data to see his mean blue score differs from the mean blue scores of other leading translation software, which has a population mean score of 0.295. Assuming the requirements are satisfied, construct a 95% confidence interval for Pharaoh's true mean blue score. All right, good heavens.
So we're going to use the QIP for this?
That sounds correct.
Yeah. And I can't open mine, so Ed, I might follow along with yours.
Yes.
Okay.
If I can,
And it's a one sample because this is just all Pharaoh.
Yeah,
Yeah.
one sample t-test. If it can, oh my goodness. I click on that tab and nothing's happening. Are you kidding me? Okay, there we go.
okay, so let me copy the data.
Okay. Mom, say goobies.
Yes.
First,
Okay.
these.
I think that my data's in.
My data's in as well.
Okay, so assuming occurrence is that, construct a 95% confidence interval for Pharaoh's true mean blue. So he wants to use this data to see if his differs. So it's a not equals to.
Type of test, not equal.
Confidence is 95.
And the null is 0.295.
Yeah.
Okay.
I think so, right?
That in, it keeps going to 0. Is anybody else getting that?
My
No,
N is 100. I have the same thing. Is this Ed's on the screen right now?
yeah.
I have the same thing on mine with a MO of 0.005.
Yeah, it won't take my 0.295 though.
Huh.
0.295?
Yeah, it won't take it. It keeps going to 0 when I input it into the spreadsheet.
That's a drag.
Up underneath where it says like the kind of number, maybe change your decimal or something. Change the kind of, I don't know. Maybe it's, rounding to 0 or something. And
Okay. Yep. Got
did
it.
it fix it? Did it fix it, Joan?
It did. Thank you so much.
Okay, you're welcome.
So the lower bound,
Mom,
0.282.
Mom, Mom.
Lower bound, 0.282.
Okay.
Fire broken.
No, but leave it outside. You don't bring that in the house.
Upper bound, 0.293.
What was the lower bound?
282.
0.282,
Okay, and the upper bound?
0.293,
Okay. Thank you.
and then 36, the degrees of freedom is 99.
Yep.
A lot of degrees of freedom, huh?
Now, we don't have to put like 0.000, right?
I don't
No,
think so.
No, degrees of freedom is kind of a whole number.
Just a whole number, right? Okay. Test statistics, negative 2.803.
I agree.
37.
Sorry. What was the test statistic again?
Negative 2.803.
Okay.
And then the p-value is a 0.006.
I agree.
Why can't that? And how do we eat? You don't eat these. He's so small.
Okay.
Is
Okay, so the p-value is really low.
efficient.
So would it be that we have sufficient evidence to say that the true mean is different than point?
Yeah, because it was just a not equal. So yeah, that very first one.
Yep.
I agree.
Okay.
I think we're coming to the end here.
They're just trying to get
Yay.
The study was done to test the notion that people are taller when they first wake up in the morning than in the evening. So this is the heights one.
No, it's not caliber. It's a fire. Okay, I'll put it back.
What did you say, John? I didn't hear you. Oh, the height.
I'm talking to myself
Yes. Okay.
because I
Yeah.
always tend to not get rid of the data before I copy, and then I can't put it in.
Yeah. Okay. Heights. Here we go.
Okay, so
So I can put it in.
No, don't bring that in here. Go put the caterpillar back.
This is going to be,
this is a paired sample t-test.
paired. And remember, post is the first column, pre is the second column.
No.
So the AM is going to go in column B and the PM is going to go in column A. Do we all agree?
Sorry. Okay, what was that? Sorry.
So the AM height or the pre is going in column B.
I want to find a butterfly. Butterflies no dog.
The PM height or the evening height, if you will, goes in column A. As my notes on my QIP, I just put in post, pre, and the difference
Right.
rather than, so that I wouldn't ever forget that because it mattered.
Which sample test? Which one is this?
This is the paired sample t-test on the QIP. So the next tab that we were just working on.
I can go outside.
And kind of like what Ed has, he's got post and pre, so that's the same kind of thing. You got to put so that the AM is going to go in column B, and the PM is going to go in column A.
But it's bound to kill it. No, it's called fine calipper.
On a port and call.
It's called fine
Whisper,
calipper.
whisper, cycles.
Listen, it's called fire calipper.
All right.
Well,
Okay, so it says the values are recorded for each child in the morning and again in the evening.
don't we want AM minus PM?
Yes.
Yeah.
Which is how it automatically figures it out down that differences column, so long as you have the AM in B column and the PM in A column. That's what the difference column is doing.
So Raylene, my numbers are, I have the right columns, correct?
Yeah, you have the same ones I do, right or wrong. Let me put it that way.
Okay, there you go, yeah.
Okay, so then when we're over at the confidence, we're just saying not equal. They're just going to be different.
Right.
Okay,
Well, the first question is
What are you doing?
the lower bound and the upper bound is the first question. So the lower bound is negative 10.331. 311, sorry.
well, that's not what my spreadsheet says.
Mine is negative 10.455.
Yeah, I was at 90%, not 95.
Oh,
10.455.
okay. Negative 10.455 is 40. Then 41 is negative 8.28.
Hot dogs out there.
728.
Okay, let me check the purchase permission.
The
That
test
seems like a
statistic,
high test statistic.
it is negative 22.446.
That is,
Yeah.
that's an extreme test statistic, isn't it?
Well, just look at the confidence interval. I mean, we're way over on the
Yeah,
left, like way. I want to say to infinity and beyond kind of thing, you know?
yep.
Degrees of freedom for 43 is 40.
Yep.
P-value 2.795.
Well, I don't have that.
Let me see what you have. Oh, that's right, because it's got that E negative 24.
So it's, yeah, I keep going out and it keeps wanting to go out to, so it's basically,
So what is
If we
that
go down to
formula
50
then? It's
if we go down to 3, you
2.79.
get zeros.
Well, when it says that E to negative 24, it's 0.
Yes.
I have 2.794683 E negative 24, which basically means 0. That's what Ed's changed his to.
Yeah, that's 24 zeros before a number other than 0 shows up. So that's a lot of zeros.
Why are we putting the AM in variable B or 2?
Because B column is the the before. You do it in the morning, and then you do it again in the evening. And so B column is the pre or the before, and the PM height is the post. So you measured them first in the morning, and that goes in B, and then you measured them afterwards. Because I remember Sister Lemon saying, make sure that post is in A, pre is in B. And so Ed has post and pre, but he also has after and before, depending on what kind of question you're doing.
Yeah, I recall Sister Lemon saying that as well. And then in the actual data, the data file, AM height.
Yeah.
It says define the differences as AM height minus the PM height.
Apple.
Yeah, so right now we're not minusing them. Or are, you know what I mean?
Yeah.
That's what I'm asking.
Yeah, because it would need to be flipped, right? That might be why our test statistic is so
So high.
high.
Outside. Melissa has her. Go see Melissa. Melissa has baby. Look
Well, I
outside.
can't imagine both Ed and I mean, I get what you're saying, but at the same time, it's how I've always done it and
Yeah.
make sure that post was A and pre was B, and I've never changed anything otherwise.
They go, for some reason, they make sure they put it in italics that say define the differences as AM height minus PM height. So is that what we're, if that's what we're doing, then I'm good. I just don't think we're doing that.
AM height minus PM height.
Right. What's the formula in there?
Well, okay, let's take the very first one. Let's just look at one. If I take the AM height for the people in 5, 1728 minus 1720,
You're going to get 8.5.
0.5 instead of negative 8.5.
Right.
Yep.
So yeah, which makes more sense.
Which is so interesting because in every other thing we've done, the post was in A and the pre was in B, because this was the chart in particular that Sister Lemon helped me do the Mo cheat, if you will. And
Well,
so I
it doesn't-
post and pre and her at her instructions, but then this example specifically, like you said, James, where they have that in italics, almost like it's going to trip you up if you don't do it this way.
Yeah.
The test
That could be-
statistic and the degrees of freedom don't change, but the confidence interval changes from negative to positive.
Yeah.
So when you switched them,
So
Joan, that statistic was still negative 22.446.
Well, it's not. Nothing's negative now. Everything's positive because.
Oh.
And if you look at the formula in the difference column, it says A6 minus B6. So you want to take whatever's in A, which they're telling you the AM should be,
Right.
minus the B. So I get what you're saying. This goes against everything we've been taught, but
Right.
I think we need to get rid of all the negatives.
Yeah, no, I think so too.
It just ticks me off.
Yeah. Yeah.
We're good. We're good. Yes, we'll just get rid of all the negatives.
So again, Sister Lemon, if you're watching, this is frustrating.
So the confidence interval will stay the same, right?
Yeah, it's just, yeah, the numbers are the same.
Okay.
It's just not negative.
Dang, I'm trying to get mine switched right now and my computer's not cooperating.
The p-value still. All right, so the p-value you're saying is 0 because it's got that E in it.
Yeah. Well, when it says like E, whatever.
I thought it was you were supposed to take like the 2.794 times it by 10 to the 24th power. I thought that's what it.
And now none of mine didn't seem to change a single thing. It didn't change anything. Dang it.
Oh, it should have changed it from negative to positive.
Yeah, it didn't. So I'm going to go back into it. I'm going to open it back up as slow as it is.
It really, and I changed them on mine if it helps you see the visual.
Yeah. Okay. Okay. Paired sample. Goodness.
Yeah, p-value is 0. Since we have to round to 3 decimal places.
Come on. just went right back to my height thing again. That's how screwy that happened to me.
What are you? Okay, hold on. So let's go back to question 40. Since I changed the post and the pre, the confidence intervals changed. The numbers are the same, but they're reversed. So the lower bound.
Okay, there we go. All right, so now I'm going back to my test.
Thank you.
Okay, so 40. So 40 is
8.728.
8.728. All right, and 41 is 10.455.
Correct.
And 42 is just take the negative out.
Right, 22.446.
Yeah. And 43 is 40, so that stays the same.
Correct.
And then 44, the p-value is 0. And I'm still supposed to do 0.000, guys?
Well, to at least 3 decimal places.
Yeah, there we go. But you never know how the computer, defaults and thinks. And
Right.
okay. Oh my goodness.
I hope I didn't steer us wrong.
No,
No, not if you read the question.
yeah.
I think you guys are accurate.
It says define the differences as AM minus PM. So if you put it in the spreadsheet, that's right.
Yeah.
I think the only reason for that is because you're taller in the morning than at night.
Right. So they don't want to show the negative.
No.
Yeah. Yeah. You're right.
Based on your test result of the test, is there enough evidence to suggest that children are taller in the morning than in the evening? So your P is low, so you're rejecting.
Mm-hmm.
So it's yes because we rejected the null.
That's what I got.
I agree.
Oh my gosh, this is freaking painful for an hour and a half.
This is painful.
All right, I'm submitting. I'm like so done. Can you tell?
Go.
Okay.
Take one for the team.
I am taking one for the team. Get the heck out of Dodge here. Ooh, 97.67. So where am I wrong?
Oh. Is that just missing one?
It's the 1600.
Which number?
Number
Which
28.
Should be
question?
1537.
Oh, that's what I did. Question 28 was supposed to be 1537.
That's right.
Can't
Yes.
Yeah.
Because I think that was the one that
Gosh, I have to write down these 40 answers.
What was number
Number
was number-
28 is 1537.
what was number 3? You got that right?
Oh, that's right. We were going to go back to number 3.
Was it 3 or 4? I couldn't remember which ones. All those ones.
Three, James, is test of 2 proportions.
Okay.
Yep, and that's correct.
What was 4?
4
is test of 1 proportion,
Okay.
and that one's correct.
Cool.
All right.
Yeah, no, I only got the one wrong. And that's
Hey.
because I just wasn't paying attention when we were putting it in. Because I can't round. I can't do a calculator and I can't round up.
No, wait, I got one
I can't
wrong.
figure out the alligator thing. So.
Oh, which one?
Let me go. Oops.
I can't.
What was I doing?
What did I do?
Oh. Also, you get them wrong if you don't click an answer. Dang it.
Oh, like save. I got 100.
I got one of mine wrong.
Which
No.
one? Which number?
I'm looking.
I can't believe I did that.
I know, I'm not redoing all
Oh,
these
it was question 5.
31 questions. I'm just going to go with the 97 points.
Okay, yeah, my question 5 is wrong as well.
Okay, I did the independent, so it was the paired sample T.
Uh-huh.